In this video, we're going to learn how to solve exponential equations. And an exponential equation is an equation that has our variable in one of the exponents. And so all four of these are considered exponential equations. So I've kept the properties of logarithms up here, and I added one more property from our last video. And that is the property of equality, and that states that if you have two things that are equal, m and n, then the log of both sides are equal as well. And I want you to notice in this property, I can't take the log of a on one side and the log of b on another. I have to take the same log, the same base, and that same base can also be the common log, log base 10. So let's take a look at solving exponential equations. In this example, I want you to notice we're going to solve this similar to how we solved exponential equations back in Chapter 6 and how we solved them in the last section, Section 7-4. I want you to take a look at these two numbers right here, 16 and 8, and I want you to notice that they both are powers of the same number. They're both powers of 2. So I'm going to represent 16 as a power of 2, and 16 is 2 to the 4th power. And I'm putting it in parentheses because 16 is being raised to the 3x power, and 8 is also a power of 2. 8 is 2 to the 3rd power. So remember, when you raise a power to a power, we multiply our exponents. So 4 times 3x is 12x, and that equals 2 to the 3rd power. And then the only way these two things can be equal is if both of them, both exponents, are equal to 3. So I'm going to set both of these exponents equal to each other and solve for x. X equals 3/12, or if we reduce that, x equals 1/4. And that's the answer to this exponential equation. So let's take a look at this next example, and if we ask ourselves, can we write 27 and 81 as powers of the same number? We can. 27 is 3 cubed, and I'm putting it in parentheses again because it's being raised to a power, and 81 is 3 to the 4th power. Okay, again, raising a power to a power, we multiply. So we get 3 to the 9x, because 3 times 3x is 9x. And that equals 3 to the 4th. And they both share the same base. So for them to be equal, their exponents better be equal, because 3 to the 4th better equal 3 to the 4th. So let's set 9x equal to 4 and solve for x. We get x equals 4/9. That cannot be reduced, so that is our final answer. All right, so now let's take a look at these last two problems, because I want you to notice, if you ask yourself, do 15 and 285, can we represent them as powers of the same number? We can't. So we're going to have to solve this a little bit differently, because we may want to actually find a real solution for our variable here. So we're going to take a look at the log buttons on our calculators. We have 2 of them, and we're going to use the common log to solve them. And we're going to use this property of equality to solve them. We have 2 things that are equal, and so in order to solve them, we're going to take the log of both sides, and I'm going to use the common log because then if we want to, we can plug that in our calculators and solve. So I'm going to use the common log, and I'm going to take the log of both sides. And here is where some of our other properties of logarithms are going to come in handy. Our variable is up here in our exponent. So why does the log help us solve? Because we have the power property. It says if we have the log of a number that has an exponent, we can move that exponent in front of our log. So we are going to move this 3x to the front of our log, and that frees our exponent. So we can actually solve for our variable. So now we get 3x times log to the 15 equals log of 285. How do we get our variable by ourselves? Well, we have this 3 and this log of 15 that are being multiplied, so we're going to divide both sides by 3 log 15. And I want you to notice that I can't just divide by our log because this whole thing is one piece. I can't separate it. Okay, so this cancels and my 3 cancels, and the only thing I have left on this side is x. And now I have log of 285 over 3 times the log of 15. We can't divide these two numbers because they're part of our log. So we can't simplify that. The best we can do is plug that into our calculator and calculate a value. And I think what we're going to do here is you guys can go ahead and plug that in. I don't have a calculator handy, but on a test without a calculator, this is an exact answer. A calculator will only give you an approximate answer because it's going to, these are not going to be whole number solutions. They're going to be irrational solutions. So a calculator will only give you an approximate solution. So let's take a look at this example down here. Again, we're going to notice that we can't represent 5 and 130 as the power of a same number. So we're going to go ahead and take the common log of both sides so that we can move our exponent to the front, and then we can solve for our variable. So we're going to take the log of both sides. We're going to move our exponent to the front by using our power property up here. We're going to say 2x log of 5 equals log of 130. We need to get x by itself, so we have 2 and log of 5 that are being multiplied by x, so we're going to divide the 2 and log 5 on both sides. And we now have x equals log of 130 over 2 times the log of 5. Again, these guys are stuck together, so we can't divide the 130 and the 5. Even though they share the same base, we cannot divide them. They are stuck together. So this is definitely our exact answer that we would give on a test, unless I ask you to plug it in a calculator and give me an approximate answer. And that is how we will solve exponential equations.